Okay.
Wow, wow, wow. Amazing, amazing responses already. Well, I
Okay.
think it is also live streaming right there in the YouTube. So if any of your friends are not able to join Zoom, then you can definitely send this recording to them. And yeah, let's get this started.
Certain silence. Okay. Nice.
Yeah. Great. So, hi everyone. This is Rukshana from Shooting Stars Foundation. I am one of the organizer of IBM Z Datathon, which is a global hackathon event for college students. This Datathon is hosted by Shooting Stars Foundation and powered by IBM. So very excited after months of preparation, from getting you all registered till this extent of the final Datathon event, right? We're very excited to keep this going. So today I'll take you through in this meeting, in this 1 hour meeting, I'll take you through the intro to Shooting Stars Foundation and the whereabouts of the IBMZ Datathon, the pre-Datathon events. You'll also get to meet your IBMZ SMEs and SSF volunteers. Followed by that, we have a keynote, out of which two of the keynote speakers are present right here. And then we'll take you through the participants to-do list. Followed by that, the datathon will, start. So, Shooting Stars Foundation, our mission is to empower individuals and communities to break the cycle of generational poverty through STEM education. We believe to educate, empower, and enable mentorship for long-term success. I request all of you to not annotate in the screen, please. All right. Okay. And we run a lot of educational programs like hackathons, skates, summer camps, and much more, right? Like entrepreneurship camps, data science and cybersecurity camps, and whatnot. So till date, our impact, we have more than 40,000 plus STEM program participants, and we have given 1,200 plus global scholarships. We have 50 US high school leaders and 9 US chapters. So when it comes to the partnership with IBM, this is the fourth year commitment to IBM Z Datathon, which is a collaborative partnership between Shooting Stars Foundation and IBM. Our goal is to promote IBM Z technology among college students worldwide. And till date, over 400 teams have projected their projects using IBM Z technology platform to address social good problems, and we have hosted hackathons, both globally, online, as well as in person in several colleges, out of which 2022 we hosted in Jaya Engineering College and PES University in India. And followed by that, on 2023, we hosted it there in Imperial College London, Savitya Engineering College Chennai, and another venue in Chennai, which is SRM IST Ramapuram. Followed by that, we also had the in-person event in the Global Academy of Technology, Bangalore. So we're hosting an additional 5 in-person event this year for this year's Data Hackathon, out of which the global is what you're witnessing today. And we are offering a value of about $30,000 in prizes to winners each year. And additionally, all the participants, they also, all the in-person winners, they get to participate in the industry conferences of the specific region. And IBM provides IBM Z mentorship to the competition winners as well. Taking that into account, this datathon is getting inducted today, and the theme of the datathon, as you all know, is Tech for Good. The team size is 4 to 6 members, which probably how you have the team name and the team number right now. And we have many categories with regards to the prizes, which is 3 categories, as you all know. And there are multiple in-person venues in addition to the global online Datathon, which is Imperial College London, Savita Engineering College, Global Academy of Technology in India, Mainz University from Germany, and TUT from South Africa. All right. So this is the statistics. We have witnessed over 9,000 plus event registrations, and out of that, we have more than 900 teams formed. We have 37 plus countries getting registered for this event, and we have had wonderful support from IBM, out of which 40 plus SMEs, including the mentors and judges, are here. And the SS of volunteers, about 15 in number, contributed for the event, with the organizers' call, emails, and messages reaching over 30,000. So here's the core team from Shooting Stars Foundation who have put together the entire marketing, getting the participant engagement, planning the entire datathon, and kind of setting and closing it out entirely throughout. So yeah, this is the moment that you appreciate all the organizers. And from the IBM side, we have Sudarshana and Shalini Priyadarshini, along with her wonderful team. So Sudarshana, would you like to say hi?
Absolutely. Um, this is always a fun event. I think we were talking a few minutes before we got started here as well. Every year, it's very exciting, to see how all of these students come together from around the world, learn about this new technology, and create some amazing, amazing solutions, which we're always, wowed by when we're going through at the end of the 24-hour datathon, right? So again, once again, thank you to everyone. Thanks to Shooting Stars for pulling this together, to all the students, the participants. We wouldn't be here without you. So thank you for being here for 24 hours, learning about this and building some wonderful solutions. Looking forward to it. All the very best to everybody.
Thank you. Thank you, Sudarshana. Well, you heard from a person from IBM who pushed this through together with us. So yeah, here, as a part of the pre-Datathon event, you also got to work on the, how to win IBM Z Datathon session. And followed by that, you also had an opportunity to witness the IBM Z Day, which is the global event that is happening across the world. And our speakers discussed on the skill acceleration part with mainframe and also about IBM Z Explore. Prizes worth more than $2,000 were given to the past students, which were yet to distribute. And as a part of the pre-Datathon event, again, you had Get Your Linux One System Ready. This event was the event that happened yesterday. So you get to set up your system with the IBM Z Linux server. So yeah, I hope you guys are all set. And these are your amazing, amazing IBM Z SMEs who will be helping you out throughout this entire 24 hours, journey. So yes, we have about, 20 plus people right here who will be helping you out in the Discord, and few others there in person who will also be joining Discord and helping out therein. So whatever questions you have for the IBM SMEs, you can only contact them in the Discord. So please go to Discord and kind of shoot your questions right there. Great. Okay. So time for the keynote session. I'd like to introduce Amit and Anbu. So these are the two keynote speakers we have from IBM today. I'd like to first start by introducing Amit Singhi. He's the director of Research India and the CTO of IBM India, South Asia IBM. So Amit, please tell us a hi, cheer us, and get started with your presentation so we can hear from you. Amit.
Sorry, I was on mute and I was saying hi
Okay.
to everyone. Good morning. Hi, good morning, everyone. Ruxana, you want me to switch over to my slides now?
Yes, yes, Amit.
Okay, let me do that. Okay, so hi everyone. I'm part of IBM, but I'm part of a part of IBM called IBM Research. So I thought I'd take a minute talk about what is this IBM Research because it's integrated with all of the things we do in AI in the company. And I'm going to give you a bit of a tour of what IBM is doing, how do we think about AI, and what are we bringing to the market and to open source in this space. So IBM Research is a family of about 3,000 researchers globally. Our India team is part of that, and globally the team works on many different foundational areas, including hybrid cloud, physical sciences, AI, mathematical sciences, quantum computing, of course, fundamental computer science, semiconductors, and also cybersecurity and cryptography. And we are very honored to have some really accomplished researchers amongst us who are Nobel laureate winners, Medal of Technology winners, Turing Award winners. So that continues to inspire us and a lot of the new researchers who join the team. If you think about what we think our purpose as, it's really to invent what's next in computing. IBM Z is a prime example of that, but more broadly, IBM is a company that has ushered in computing into the business world, and we view ourselves as having a mission around that for the world. And in research, we try to invent what's next and work with the rest of the company to bring it to market. And today, if you see the key three vectors that we think are already defining the future of computing, these are AI, quantum, and hybrid cloud. Hybrid cloud, I'm not going to go into hybrid cloud and quantum today, but I just wanted to make sure you understand the broad landscape within which we are also looking at AI. Okay. So let's switch and focus a little bit into the area of AI, what we are doing there. Uh, I think many of you would be familiar that AI has been around for decades. It started off with these basic expert systems. It was not called artificial intelligence then. This was in the 60s or so, where you had rules-based systems that were coded up to do clever things. And then in the 90s, machine learning really became a big deal, where we could actually take data and have the computer learn from the data and sort of become a learning program, and then use that learning to drive predictions, classifications. That got supercharged in the 2010s with deep learning, with the advent of GPUs and more powerful computing, and with a lot more data available through the internet, so that researchers could figure out large neural networks that had the capacity to learn from very large data sets and to use that large computing, but using the same principles, fundamental principles of machine learning, to achieve very high performance, reaching human level of performance on certain tasks. And then now we are in the era of foundation models, which is a kind of deep learning basically, right? But there's one conceptual advancement that has happened where now you train these neural networks on, I think there's a lot of nice annotation happening. I request all the attendees to not annotate. The foundation models are trained on large amounts of unlabeled data, so they become really good at a particular domain, which may be like language or code, and then you can quickly adapt them to different tasks. And you're probably familiar with some of these from different companies available out there. A lot of the models available out there have seen a huge amount of the public data that's available on the internet. But the reality is that they've hardly seen any of the enterprise data. This is the data that is inside companies, that is related to the business of companies, whether you're a bank or a retailer. There's a lot of, let's say, operational data you have, sales data, customer related data. All of that is not on the internet. That is inside the protected servers and storage of these companies. And so these models that are out there have not really seen this. And if you try to chat with a model and ask it questions about, let's say, some of the historical sales within IBM, there's no way it's going to know that because it's not seen that data. And that's the lens we take in IBM because we are working to the service of these companies and enterprise clients. And so our overall mission is how do we make it super easy for these companies to build their own AI and make sure that their enterprise data is represented in that. And one of the ways that people do this, are trying to do this, is to take an existing foundation model like a Granite model from IBM or a Llama model from Meta, and then do different kinds of customization on it with your own data. For example, you can do fine tuning or parameterized efficient fine tuning, or you can do prompt tuning to make that model more aware of the enterprise data that you have, right? But this is, it looks simple, but it's not a trivial task. And let me walk you through a little bit of graphics to help you understand what we're trying to do here to make it easier. So here is just a picture of, traditional AI models. We used to build one model for each task, right? So if you want to predict, classify sentiment of a text, you would take a lot of text data and sentiment data and train a model for that. If you wanted to do something like summarization, you would do that whole process again. So a separate model for separate tasks. Now in the foundation model era, we have one big foundation model. And then when you want to apply to these different tasks like summarization or sentiment analysis, you can work with almost zero label data or a few hundred or thousand data points to customize it for that task. And then you can further prompt it and use advanced prompting techniques to customize it even further. But how do you do all of this? It doesn't just happen in the air, right? And this is where what clients need to do typically is bring their in-house proprietary data, which has all of the company related information, historical data, together with third-party data, which might be from external sources like GitHub or Wikipedia, and be able to tune and train models with that combination. And when they want to do this, they don't want to send their secret data over to the internet to somebody else's cloud or servers. They want to have it in a secure computing environment. And these data sets tend to be very large, easily in the terabytes, sometimes in tens or hundreds of terabytes or even more. And so you need also software that can handle, software hardware that can handle this data at scale, tooling that makes it easy for you to run these tuning jobs, and have a catalog of foundation models that you might build for different purposes, so that you can then use this for all kinds of different tasks within the enterprise. So there are certain principles that are important here, right? The ability to use multiple models of your own choice, because the models that are good today may not be good 2 years from now. Maybe you need something new at that point. You need tools to accelerate the whole, software engineering process, but this is for AI engineering. You need to be able to govern and handle these large amounts of data to make sure there's no bad data in there, there's no copyrighted data in there, there's no hate, abuse, and profanity data in there. And you need to be able to move this whole software anywhere you want. It could be on your on-premise data center, it could be on IBM Z, it could be in the cloud. You don't want to re-implement if you want to redeploy these things, right? So you need a portable architecture. And this is where we've developed a software called watsonx to allow big companies to do this in-house. And watsonx has three major parts. There's watsonx.data, which is a software portfolio that can handle these large amounts of data. It's called a lake house, and you can manage that data anywhere you want. There's watsonx.ai, which is the set of tools that lets you prompt different kinds of models, manage a model catalog, do fine tuning, deploy it and serve it from anywhere you want. And then watsonx.governance, which monitors and measures different metrics on the models you build so that you can measure what is the quality and performance of the output, is there any bias issues with the model, and feed that back into the entire life cycle of the model. Okay. And all of this is built on top of a completely containerized best of breed software architecture that is implemented by Red Hat OpenShift. That's a Kubernetes distribution that IBM Red Hat has, and it's very portable. You can deploy it on the IBM mainframe platform. You can deploy it on AWS, on IBM Cloud. So that means all of the blue software doesn't need to care what is the underlying hardware. It can work anywhere you want. Now, talking about foundation models, it's not just language. It can be many different data modalities. So I'm not going to go into all of these, but I wanted to make sure that I convey that we're working on all of these many different data modalities, such as text and code, geospatial data, time series data, data that comes from IT systems, and so on, right? So LLMs is only one part of this landscape, but foundation models is a more general version of these large language models. And just to give a view of the kind of models we are building in IBM, and these are already out there in the open, the approach we have taken is to put all of our models in these different areas in open source so that anybody can use and build on top of that. We call this whole model family as granite because granite is a very strong foundation. It's a strong rock, so it's a strong foundation on which companies can build their AI technology. This picture is just showing a 8 billion parameter granite model. The blue bars are the tallest bars, and that's just showing the performance of the granite model when compared to other open models in the same size category. So we are very proud to note that our models are very competitive with high performance, and we have open sourced them with the Apache 2 license so that they're easy to use in any kind of product by anybody. Additionally, we are very, very conscious of ensuring transparency of the kind of data that goes into the model and making that visible to anybody who uses it. And for that, a study done by Stanford actually rated us amongst the top few models out there in terms of transparency also. And this becomes very important for companies who are picking up a model to start their AI journey. A quick look at a non-language model. This is called the Granite Tiny Time Mixer. It's a time series model, so this does not take text in as input, it takes time series data. Quickly, if you see the picture on the left-hand side, it shows model size. And the last one is the Granite TTM model. You can hardly see the bar, right? The point is an extremely small model with just under 1 million parameters. However, when you look at the quality on the right side in terms of the error of the output, you can see the blue bars are the smallest. So we actually achieve the highest performance, highest quality with the lowest resource consumption with the TTM model. And this is also really exciting. Now I'll take just a couple of minutes to talk about what do you do with these models and what is the innovation we are bringing to help companies take these models and show them their enterprise data, right? So going back to our original picture, we know that hardly any enterprise data has been seen by these models. So our mission here is to enable companies to represent their enterprise data also with foundation models so that they can unlock that value. So how do they do that? Right? Step one, they start from a trusted base model, which generally knows a particular domain, like maybe it knows English really well, right? So I talked about the Granite family. That is a very trusted model because of its transparency, its open source, and the indemnity that IBM provides. The second step is to create the representation of your own data because even Granite has not seen the data that is inside a bank, right? And so the bank would need to take Granite and update it to represent the data that they have. Now, typically today, until now, the methods that existed were typically things like retrieval augmented generation, where you take your custom data and put it in a vector database and then use that in the prompts of the model. This is great, but it doesn't actually improve the model itself and doesn't update the model. So every time you need to rely on this external database. The other approach is to do fine tuning. The challenge with fine tuning is for each different use case where you want to apply the fine tuned model, you end up with a whole catalog of many models that you have to manage. Right. And so IBM came with a breakthrough called Instruct Lab, where the idea is, let's say you want to create many different skills on the base model, something for HR, something for procurement. Then Instruct Lab allows you to have almost like a GitHub, kind of community development flow, where you can take the base model and add skills to it over time, add knowledge to it over time from different domains, so that you bring all of that together into a single a single customized model. And how does it work? There's a command line interface of Instruct Lab where developers can use that command line interface to submit skills, and skills are simply just examples of, okay, if you instruct the model to, let's say, summarize some text, what does the summary look like, right? So a few examples like that. There's a backend process which triages those skills, uses those skills to generate a lot of new data, and then pushes that into a fine-tuning workflow. It's very simple in concept, but it allows a whole group of skill developers to contribute these skills and create a custom version of Granite, which can be used for so many different tasks within the company. Okay, and then final step would be to deploy this somewhere, and I talked about all the nice watsonx architecture. So this is just a vertical view of it, where you have watsonx running on OpenShift AI, and then underneath that you also have Enterprise Linux AI. And in fact, when we are deploying these on IBM Z, we use a very similar stack with watsonx and OpenShift, also on IBM Z, because that gives us that portability. Okay, so with that very quick overview, Anbu, I hand it to you for your session.
Thank you, Amit. Share my screen.
Hi, Anbu. Okay, everyone. So Anbu was also there last year. He did a keynote last year for us as well. And Anbu is the distinguished engineer from IBM Zealand Next One Development IBM team. So welcome, Anbu. We are very excited to hear from you.
Thank you, Rakshana. Thank you, Amit, for the excellent overview on AI. So let me touch upon the enterprise computing and how IBM Z and mainframe play a role here. So, what do we do every morning, right? We look at social media, right? A lot of things to learn from social media. Like if you want to learn what's happening in AI, there's a great source of information available every day on social media, right? Let me show you quick statistics of what happens in 1 second in some of the major social media, platforms that is out there currently in the world, right? As you can see there, right? There's about 1,200 Instagram posts coming in per second, right? 100K Google searches, right? You can see the volume of social media posts that's happening every second. And in contrast to that, I'll show you the quick statistics of what's happening in IBM Z or the modern mainframe, right? As you can see here, over 1 million transactions that are happening every second on an IBM Z or mainframe. So you may be wondering that what's happening with those transactions? Who is making those transactions? The answer is, not to be surprised, it's you, right? And all of us here, right? We are the one who is making these transactions. Every time you swipe your ATM card, every time you swipe your credit card, right? You try to book an airline ticket, right? You want to, do an insurance claim. All of them, when you do, you're actually hitting a mainframe on the back end, right? It's not visible to the normal users, but it is certainly there. And as you can see there, right, 7 out of top 10 retailers, the top banks in the world, all of them use mainframe as their backend for doing the transaction processing. And if you look at the architecture, right, that's why we call it as IT's best kept secret. It's because it's invisible, but it is there, providing the reliability, availability, security, right? And resiliency that is required for running this mission critical applications and transactions for the workload. See, as you can see here, right? I mean, so what do? We use our mobile phones to do a transaction, like booking a ticket, or making a online transaction, like buying your favorite phones, right? When we do that, what's really happening is that it goes through various interactions through APIs and integration services, right? There's usually an web server, an application server that's running in a cloud, right? And there is authentication and authorization, and then a range of APIs and integration services. But ultimately, as you can see there, right, IBM Z or the modern mainframe is where the transaction happens, and that's where the transaction gets completed before you get the acknowledgement that you are successfully completed the transaction, right? And that's what happens within a millisecond, because all of this happens so quickly, and that's where IBM Z is really playing a key role. So when we talk about IBM Z or the modern mainframe, right? Yes, there are many applications which have been written over the past decades. Like potentially it could be in COBOL, it could be in languages such as Rex or JCL. And when Amit spoke about the Granite models and AI, these AI are used to actually modernize your applications, right? It could be refactoring, enhancing, modernizing your application. So today we use AI for doing that. And as you can see in this chart, right, mainframe is not only about the older languages, but also about, all the stuff, right? You can do Java, you can do Python, you can do containers, you can do Kubernetes, right? You can run the modern databases. And this is where, right, your skills, and I'm sure you have learned many of this stuff in your college projects and other things. You can apply it, right? And in the Z Datathon, you'll be using many of these tools, including the latest open source AI tools and frameworks that we can use to build AI applications. And infusing AI is part of the modernization journey, right? You can take an application which has been running and then infuse AI to that in various forms. So that's essentially what we do in terms of integrating open source and leveraging that in enterprise applications. So for all of you who are following the news around, right, every year, we have something called the Hot Chips conference that talks about the processor architecture and the new things that are happening in the industry. So this year in the Hot Chips conference, we have announced from IBM the Telum 2 processor along with the Spire accelerator. So this is going to be part of our next generation of IBM Z and Linux One. Internally, we call it as Z Next or the Linux One Next. So this is going to have several advancements to the enterprise computing as well as to the AI. For example, you can see this DPU component, the data processing unit. It's all about reducing the latency and power required for your IO processing. We are moving a lot of IO processing logic into the processor chip itself, right? You can learn about how the virtual L2, L3 cache architecture we introduced in Telum, continue to enhance that in Telum 2. And then, the on-chip AI accelerator that sits within the processor itself and shares the memory. So that is being enhanced. And then we are now introducing Spire accelerator PCA attached card that will provide the required compute power to run the large language models, such as the Granite models that Amit spoke about, right? All of them is going to enable what we call as the ensemble approach to the AI, allowing users to run both the traditional ML/DL algorithms as well as to run the large language models and combining them for specific use cases that are required for the industry. So overall, tremendous innovation happening around IBM Z that is going to kind of leapfrog us into the next set of applications and use cases that's coming out in the future. Right. The second area that I want to talk about is the whole concept around quantum computing and quantum safe cryptography or the post-quantum cryptography. Amit, in fact, just talk about some of the industry trends here. Did mention about quantum computing, right? And if you are following the news, that you would have seen a recent announcement just a few days back, right? That there are quantum computers that can break encryption algorithm, including the RSA algorithm, right? So you can read about it online, but essentially the quantum computers are not like the classical computers. They are based on quantum mechanics and concepts around superposition and entanglement, right? If you want to read more about this, a fun way to understand and read more about superposition and entanglement, read about this concept called Schrodinger's cat, right? You can learn about it online and how it relates to superposition and entanglement, right? But I'm not going to go to that in detail, but essentially what we are saying is the quantum computers at some point of time can be large enough to break traditional encryption algorithms, and that's where there is a need for quantum safe cryptography. And IBM Z and the modern mainframe have quantum safe cryptographic algorithm support already, and we continue to enhance it to enable future proofing encryption that is required for the businesses around the world. So net what is happening is that you saw about the evolution of AI, what the new systems that we're introducing, how we are integrating AI, how we are responding to some of the challenges like quantum safe. And net what is happening is that the industry survey that we have done is talking about the need for mainframe and IBM Z skills, right? There is a huge market out there for application modernization. A lot of new workloads that are coming to the mainframe. Linux runs on mainframe, but AI applications, right? Microservices and containers. So overall, there's been a tremendous need for skills, mainframe skills, as companies grow their footprint and adopt new Linux and AI based workloads. And it's we want to let you know that there is opportunity to learn mainframe and build a very successful career if you're interested in this path, right? And that's and IBM is certainly helping all of you here, right? That the Datathon here is a great opportunity to expose the technology and concepts around the mainframe. But there are also many programs, right? For example, Z Explore, it's a free program, right? That has a progressive learning roadmap. You get hands-on access to the Z environment, and in the end, you also get the industry recognized badges that you can add it to your resume and whatnot, right? So there are many ways in which you can learn IBM Z and technologies in it and concepts. Certainly, the Datathon is a great platform, and we want to thank you for signing up for the Datathon, and we look forward for many interesting ideas and showcases coming out of this. So probably stop here. So that's what I wanted to cover.
That's awesome, right, Amit and Anbu. So I've been encouraging the students to ask some questions here on the chat while they're putting their questions there. So one question that I often get when I'm speaking to students and talking about IBM Z, so I'll open that to you and Amit, right, Anbu? If you want to be, a cybersecurity specialist, or if you're looking at AI and want to be in the space of AI, or, you're really interested in infrastructure and want to dig deeper in infra, the question I always get asked is, can I be on mainframe and do all of this? I know the answer, but I'd like for one of you or both of you to share your thoughts around this question that we often get asked.
Absolutely. Absolutely, Sveshna, right? I mean, AI, right? Amit spoke about AI, right? The granite models. We are currently using AI to modernize the applications on the mainframe, right? For example, what's the next code assistant for Z that Amit and team have built, right? Amit can talk more about it, but essentially it's about using the large language model to automatically understand and refactor COBOL applications, how it can be even migrated from a COBOL language to an object-oriented language like Java. So that's a great example. The other example is like fraud detection, right? There are a lot of transactions happening on Z. There is also some transactions which could be fraudulent. So we are using AI to detect frauds, right? For example, like an XG boost, algorithm can be used and deployed And this algorithm can run when the transaction is happening. So it's happening in the context of the transaction window, and it can identify whether the transaction is valid or fraudulent, right? So there are many cases in which we are using infusing AI into the mainframe applications. Security, right? I already spoke about quantum safe cryptography. There is also other areas that IBM Z is leading on the security front. Is confidential computing is another area, right, where we have an ability to protect the data in use, apart from protecting the data at rest and data in motion. So there are, tremendous, and the other area that we are introducing is AI-powered security. How can we use AI to identify threats and mitigate them before it's happening? So overall, right, there is just so much opportunity. I'll also let Amit to share some of the opportunities around AI because he's an expert in this. Go ahead, Amit.
Hey, Nanbu, great points. I'll just add a little bit more. In fact, for Z, top to bottom, we are seeing AI come together, right? All the way from the chip till the end user and everything in between. And apart from WCA for Z, apart from the Spire chip, which is super exciting, um, there's also Watson X Assistant for Z that actually automates tasks for you if you're a system programmer and you need to change something in the middleware and you don't know, you have to go read the documentation, all of that. Watson X Assistant has the AI to just go off and automate a lot of those tasks. And the big disruption that's happening in the AI world now, LLMs is like old news now. The new thing is agentic workflows where these foundation models are being used to not just explain text or something like generate code, but to perform more complex work, which is ill-defined. And we are working very intensely between the research team and the Z product team with a lot of the engineers from the Z business unit, working together to create more advanced chat capabilities with agentic capabilities, which will let you do many more things on the Z platform. So that watch out for that coming next year.
Yeah, and I feel like never in history has it been more exciting to be part of technology, I think, right? Even when the computers came to becoming a thing, I don't know if it was as exciting as today with all this AI technology that is coming to life. I think it's a great time to be a student, to be learning about all of this and putting these things as you learn into action. So with that, not taking too much time away from the students and their 24 hours that they have to learn about Z and Linux One and the platform that we are offering them, right? A containerized open source machine language, tools and tools that are available to them on any other platform, and being able to run it on a Linux One using our Linux One community cloud as the offering through this 24 hours. I think it's a great learning opportunity to really see some of what Amit and Anbu were talking in terms of the power and the scale of the platform in action, right? Hands-on. So make the best of it, right? For all of the students and all the teams that have registered and who are here today, make the best of this opportunity. And I will just say good luck, all the best. Can't wait to see what you build. Amit,
Yes.
Anbu, would you like to share anything as you close it out?
Yeah, good luck everybody, and I'm excited to hear back, Sudarshana, what the students do here, and just use the time you have.
Same here. Best wishes, everyone.
All right, Rakshana, you want to wrap up with some Datathon details for the students?
Yes. Yes, okay. So dear students, the hackathon guidebook is already shared in your mail and also in Discord and in your WhatsApp groups. So the Discord channel link, we've also dropped it right here in the chat. So in Discord, there is a text channel named as IBM SME Help. So that is where you can ask your questions, and IBM SMEs will help out. So we from Shooting Stars Foundation will be there, with whom you can clarify all your, deck-related queries. And for technical queries, you can always reach out to this chat channel, IBM Z SME Help. And adding on to that, as a participant, your to-do list would be to finalize and review your idea, then code the solution, as we can see, and test it in the platform, create the presentation deck. The presentation template is already shared in the platform, Hack to Skill, and prepare your pitch, mock the pitch with mentors, make changes based on the mentor's feedback, and the required submission guidelines that also we have shared with you. So a flow chart, if you can include that, is also an optional one, but yeah, that's more good if you can include that. And as a participant, you will be just generating ideas with your team and, picking up an idea and drawing out the final layout for it. And while you split up the work and, do things evenly, make sure that you're all doing it correct. And yeah, always, even if you falter, we as mentors are always there to, take you back. And a begin development, like start your project in the Linux 1 IBM Z systems and a kind of work on the basic features, and depending on time, keep adding more. And as I said already, just validate the idea and request for any coding help throughout the entire 24 hours duration. And the projects, the submission guidelines, which is already shared, will have two key pointers. One is the Hack to Skill link that we have shared in the guidebook, and you'll also create the presentation and a video explaining three your entire project, the problem, solution, technology, in about 3 minutes. And yes, with that, let the hacking begin. Okay, congratulations everyone for taking this first step. We hope to really see you guys thrive in this entire 24 hours, and finally bring your project to life. Good luck.
Bye. Good luck, everyone.
Okay, then. See you all. Bye-bye.